Hello everybody. Now in this video, after the introduction, we are going to discuss some ADAS specific terminologies which we will be using extensively throughout this tutorial. Alright, now let's see some ADAS specific terminologies. The first important terminology is ego vehicle. This is a very important word which we will be using throughout the tutorial. Now what is the ego vehicle? What is meant by ego vehicle or host vehicle? It is called both ego vehicle and host vehicle, but usually in the ADAS jargon, ego vehicle is more popular. The ego vehicle, also called host vehicle, refers to the vehicle equipped with ADAS autonomous systems, the car that is aware of the surroundings using sensors and computing. So whenever I am talking about a car which is equipped with all the ADAS systems, that particular car is addressed as the ego vehicle. It is the reference point of all perception, decision making and control actions. Okay, understand this sentence very carefully. It is the reference point. Okay, for example, in this drawing, if you see this drawing, there is one ego vehicle and there is a reference and based on this reference point, the relative distance and angle of the other vehicle is calculated uh, or addressed. Okay, next comes the key characteristics. Now what is the key characteristic of the ego vehicle? It is equipped with sensors like radar, lidar, cameras, ultrasonic to detect the surroundings, and it also runs perception algorithms like object detection, lane detection and path planning. Now coming to next important characteristic, it makes driving decisions like braking, steering, accelerating based on sensor inputs. Alright, and also often used in simulation as self vehicle when testing ADAS function. Now self vehicle is also a kind of ego vehicle, but this particular jargon or terminology or nomenclature is especially used during simulation. Now let's see one example scenario. If a car has adaptive cruise control, the ego vehicle is the one that automatically adjusts the speed based on the distance to the car ahead. So the ego vehicle is the vehicle which is equipped with adaptive cruise control. Next important terminology is the target vehicle. Okay. Now target vehicle also may have ADAS features, but when we address one particular vehicle as a ego vehicle, all the vehicle surrounded or detected or referred by ego vehicle sensors is called target vehicle. So definition is, a target vehicle is any other vehicle detected by ego vehicle sensor that influences its behavior. Okay, for example, if this is the ego vehicle, then this is the target vehicle. Okay, so clearly understand. So whenever we label or adjudge a particular vehicle as a ego vehicle, all the surrounding vehicles are addressed as target vehicles. It can be a car, truck, motorcycle or any moving object that ADAS system needs to track and respond to. Now coming to the key characteristics, it is detected by sensors, radars, cameras and lidar. Now tracked over time to predict its movement. Example is braking, changing lanes. Next comes classified based on risk. Example, a car cutting into ego vehicle's lane is high priority target. Alright, so these three key characteristics are very important. Now again coming to some example scenarios, adaptive cruise control, the ego vehicle follows a target vehicle ahead while maintaining a safe distance. You understand? So ego vehicle is a vehicle which is equipped with the adaptive cruise control, and target vehicle is a vehicle behind which we are maintaining a safe distance. Next comes the automatic emergency braking. If the target vehicle suddenly brakes, then the ego vehicle reacts by slowing down or stopping. So ego vehicle is the vehicle which is equipped with the automatic emergency braking, and the target vehicle is the vehicle ahead of the ego vehicle which when it suddenly brakes, the ego vehicle also comes to stop. And coming to lane change assist, the ego vehicle checks for the target vehicle in the blind spot before changing lanes. Understand this sentence carefully. So the vehicle which is equipped with lane change assist, whenever it is changing the lane or going to the adjacent lane, it checks for the target vehicle in the blind spot before changing lanes. So target vehicles are all the vehicles in the blind spot. Now, what are the key differences between ego vehicle and target vehicle? Okay, and why are these terms so important? Now, first let's see why are these terms so important. Now, when it comes to sensor fusion, it helps distinguish between the car's own data and external data. There is a huge, a big chapter about sensor fusion. When you come to the concerned session, you will understand what sensor fusion is. As of now, you understand that sensor fusion is a very important act or very important activity in the ADAS. All right. Now, when it comes to path planning also, the ego vehicle must navigate around the target vehicle. Path planning is nothing but planning the path of your ego vehicle. Now, also coming to the collision avoidance, the ADAS systems prioritize which target vehicles pose the highest risk. Coming to testing and validation, engineers simulate scenarios where the ego vehicle interacts with multiple targets. Alright, so testing and validation, engineers simulate scenarios where ego vehicle interacts. So, and I already told you, when it comes to simulation, ego vehicle is also called the self vehicle. Alright, now let's see this comparative table. When it comes to, we are comparing the feature between the ego vehicle and the target vehicle. Now, when it comes to the role, the self car with the ADAS and target vehicle is the other vehicles detected by ADAS. When it comes to sensors, ego vehicle has the sensors like radar and camera, and target vehicle is the vehicle which is detected by ego vehicle sensors. And when it comes to control, it makes decision like brake, steer, and this target vehicle is the vehicle which influences the ego's decisions. Now, in simulations, the vehicle is being tested and all the other vehicles in the scenario are called target vehicles. Now, when it comes to real world example, for example, highway driving with adaptive cruise control, your ego vehicle is a car where ACC is enabled, and target vehicle is target vehicle 1, a truck ahead that your car follows at a safe distance, and target vehicle 2, a motorcycle approaching from the side tracked for the lane change safety. Now, because you are in the initial part of the tutorial, you may or may not know what is ACC means. Okay, there is a separate module where I am going to clearly explain about this ACC. Once you familiarize yourself with ACC or adaptive cruise control, you will more clearly understand this particular real world example which I am demonstrating here. Okay, target vehicle 2, a motorcycle approaching from the side tracked from lane change safety. So, when it comes to lane change or lane keeping assist, then this target vehicle is the vehicle which is sensed or perceived by the ego vehicle in the blind spot. So, the ego vehicle's adaptive cruise control system adjusts speed based on target vehicle, while the blind spot detection monitors the target vehicle too. Okay. Again, don't get confused. As I said at the beginning of this is a tutorial. You need to revise at least 2 times. Okay, only then it will make perfect sense, because these terms I will be explaining more in the subsequent chapters. Next important terminology is ego coordinate system in ADAS and autonomous driving. I want all of you to see these pictures very carefully, and to be very honest with you, this is very in-depth chapter or very fundamental chapter. So this is not very much used when you are actually developing an ADAS system, but for the sake of knowledge, I strongly recommend you learn these things. The ego coordinate system, also called vehicle coordinate system, is reference frame centered on the ego vehicle. Okay, so coordinate system which takes the reference of the ego vehicle is called ego coordinate system, and it is based on this coordinate system the relative position of the sensors and autonomous other systems. It is used to represent the positions and movements of the vehicles, movements of the objects like target vehicles, pedestrians, lanes, etc., relative to the ego vehicle self. Alright, and this system is critical for sensor data fusion, object tracking and motion prediction, path planning and decision making in autonomous driving. Okay, now when it comes to ego coordinate system, I recommend that you go through the definitions very clearly. A two-dimensional reference frame where ego vehicle is at origin, used for basic ADAS functions. Okay, and when it comes to axis and conventions, x-axis takes care of the longitudinal, y-axis takes care of the lateral. Longitudinal means forward direction of the ego vehicle, and y-axis is left right direction perpendicular to the x. So please understand that we are right now talking only about the 2D dimension. And for example, a target vehicle is detected 10 minus 2 means it is 10 meters ahead and 2 meters to the right. Alright, another example is a lane marking at 0 1.5 means it is 1.5 meters left to the ego vehicle. So what is the main limitation of the 2D ego coordinate system? The main limitation is it does not account for height of the vehicle pitch and roll, and it is suitable only for basic ADAS, something like lane departure warning. It is not exactly suitable for other features like vehicle turn assist or blind spot detection, which I will be explaining in the coming sessions. Now again, 3D coordinate system is a 3D coordinate system. I request all of you to see these drawings which I clearly mentioned this 3D coordinate system. If you require, you pause the video and try to study these things, but of course I will be explaining. A 3D dimensional reference frame that includes height and often vehicle orientation, roll, pitch and yaw used in autonomous driving, advanced ADAS like pedestrian detection, 3D path planning. Okay, and when it comes to axis and conventions, x-axis and y-axis are same like 2D ego coordinate system. X-axis is forward direction and y-axis is lateral left or right direction. And when it comes to z-axis, it is up down direction. So naturally XYZ axis has origin 0 0 0, usually at the center of the mass of the rear axle. Always remember that origin is the center of mass of the rear axle. If you see this vehicle, there is a rear axle and the center point of that axle is considered the center of mass. Now coming to the additional parameters for the full 3D motion, yaw is the rotation around the z axis, pitch is the rotation around y axis and roll is the rotation about x axis. These three parameters are extremely important in programs like or ADAS features like electronic stability control, electronic stability program, because based on this is the vehicle stability is clearly adjudicated. Okay, next is example usage. A pedestrian 5 minus 1.5 means 5 meter ahead, 1 meter for right and 0.5 meter tall. A vehicle light at 15:05 means 15 meter ahead, centered 5 meter high. And coming to the advantages over 2D, of course it is advantages over 2D because it captures the elevation changes and it enables the 3D object detection, and it supports the full vehicle dynamics including pitch roll in of off-road driving. The biggest advantage is it gives a more clear-cut precision location reference to the ego vehicle. Alright, so hope everybody understood what is the 2D coordinate system and 3D ego coordinate system. Now this comparison I will leave it to you. I request all of you pause the video and go through this thing because I have already explained this very carefully, and I will just briefly touch upon why is the ego coordinate system so important. Now ego coordinate system is important because all sensors, radars, lidar, camera report detection in the same coordinate system. So we require a standardized coordinate system to identify the location of the target vehicle in reference to the ego vehicle. That is why a standardized reference frame or a standardized ego system is important. Now coming to easier motion prediction, if a target vehicle is 20 minus 1.5, ego vehicle can predict its path relate to itself, especially when you are doing automatic emergency braking or emergency vehicle swerving. Okay, then the target vehicle position identification becomes very important. Now next comes the path planning and control, and the autonomous system computes steering and acceleration based on the obstacles in ego coordinates. Now coming to simulation and testing, ADAS algorithms are tested in virtual environments where all objects are defined in the ego coordinates. Especially for simulation and testing where the vehicle is addressed as a self vehicle, these ADAS algorithms are based on virtual environments where all objects are defined in ego coordinates. So, to understand the relative position of the other vehicles in the virtual environment, based on the ego coordinates itself, the simulation is carried out. All right. Now, another real world example is the ego vehicle approaches a curved road with an oncoming truck. Then what are the 3D ego coordinates? The truck position is 30 to 1.5 means 30 meter ahead, slightly left and 1.5 meter height. So, slightly left means 2 meters left side, and also the road curvature yaw rate is 0.1 radian per second and it is turning right. Also, system response is I adjust the steering to stay centered while maintaining a safe distance. Okay, so this, for the sake of this system response, or to enable this system response, this 3D ego coordinates play a very important pivotal role. Okay, so hope you understood all the various kinds of terminologies which are used in this ADAS tutorial. Thank you.